For as long as we have looked up at the night sky, we have asked questions. What are those twinkling lights? How far away are they? Are we alone in the vast, dark expanse of the universe? This innate curiosity is a fundamental part of what makes us human. We are explorers by nature, driven to push the boundaries of our knowledge and venture into the unknown. The story of space exploration is the story of this very drive. It is a grand narrative of human ingenuity, persistence, and our relentless desire to understand our place in the cosmos. From the first rockets that broke free of Earth's gravity to the robotic explorers now wandering the surfaces of other worlds, each mission is a new chapter in this incredible journey of discovery. This journey has taken us to remarkable places. We have walked on the moon, sent rovers to Mars, and flown probes past the giant gas planets, Jupiter and Saturn. Each destination has offered new insights and, invariably, more questions. The universe, it seems, is far more complex and wonderful than we could have ever imagined. The more we learn, the more we realize how much is still left to discover. This feeling of wonder is perhaps most potent when we look towards the very edge of our own solar system. For decades, Pluto was just a faint, blurry point of light in our most powerful telescopes, a tiny, mysterious world at the frozen frontier. Its secrets were locked away, waiting for us to make the long journey to find them. The exploration of these distant realms is not just about collecting data or mapping new territory. It is about challenging our own understanding of how solar systems form and evolve. It is about testing the very laws of physics in extreme environments. When we send a spacecraft like New Horizons across billions of kilometers of empty space, we are sending a piece of ourselves, our curiosity, our ambition, and our hope for answers. The information it sends back across that immense void does more than just fill textbooks. It inspires a new generation of scientists, engineers, and dreamers. It reminds us that there are still great mysteries to be solved, and that the next shocking discovery could be just around the corner, waiting in the cold and the dark. And so, we look to Pluto. This small icy world, once considered the ninth planet, has become a symbol of the ever-changing nature of science. Its reclassification as a dwarf planet did not diminish its importance. If anything, it made it even more intriguing. It became the gateway to a whole new region of the solar system, the Kuiper Belt. This vast icy debris field holds the building blocks of our planetary neighborhood, preserved in a deep freeze for billions of years. The story of Pluto and what lies beyond is a tale of unexpected wonders, of scientific puzzles, and of the profound realization that our solar system is a far more dynamic and mysterious place than we ever knew. To unlock the secrets of this distant world, NASA embarked on one of the most ambitious missions in the history of space exploration. The mission was called New Horizons. Its goal was simple to state but incredibly difficult to achieve: to travel for nearly a decade and across more than 3 billion miles to perform the first ever flyby of Pluto. Launched in January 2006, the New Horizons spacecraft was the fastest object ever sent from Earth. It was a marvel of engineering, a compact probe packed with sophisticated scientific instruments, all designed to operate in the extreme cold and darkness of the outer solar system, far from the life-giving warmth of the sun. The journey itself was a testament to careful planning and precision. To gain the necessary speed to reach Pluto in a reasonable timeframe, New Horizons performed a gravity assist maneuver around the giant planet Jupiter in 2007. This cosmic slingshot flung the spacecraft onward, accelerating it towards its distant target. During its long trip, the probe spent most of its time in a state of hibernation, a deep electronic sleep to conserve power and protect its systems. Periodically, its human controllers on Earth would send a signal to wake it up, check its health, and make tiny course corrections, ensuring it would arrive at the right place at the right time nearly a decade later. As the years passed, New Horizons flew silently through the vast emptiness between the planets. It crossed the orbit of Saturn in 2008 and Uranus in 2011. Finally, in 2014, it crossed the orbit of Neptune, the last of the giant planets, officially entering the realm of the Kuiper Belt. Back on Earth, anticipation grew. Scientists and the public alike watched as the mission team prepared for the main flight. In early 2015, New Horizons began its final approach to Pluto. The faint dot of light that had been its target for so long slowly began to resolve into a distinct world. Features and symptoms no one had ever seen before. The climax of this epic journey occurred on July 14, 2015. On that day, after a voyage of 9.5 years, New Horizons threaded a precise path through the Pluto system, flying just vast amounts of data. It studied Pluto's atmosphere, mapped its surface, and measured its temperature. Then, just as quickly as it arrived, it sped past, continuing its journey deeper into space. The data, traveling at the speed of light, would take hours to cross the solar system and reach the eager scientists waiting back on Earth. When the first detailed images and data from New Horizons began to arrive on Earth, the scientific community was left in a state of collective shock and awe. The Pluto we had imagined, a simple, cold, and geologically dead ball of ice and rock, was completely wrong. Instead, the pictures revealed a world of stunning complexity and breathtaking beauty. The surface was not a uniform, crater-covered landscape as many had expected. It was incredibly varied, featuring vast plains of frozen nitrogen, towering mountains of solid water ice that reached heights of several kilometers, and deep, mysterious canyons. The sheer diversity of the terrain was completely unexpected for such a small, cold body, so far from the Sun. One of the most surprising discoveries was that Pluto appeared to be geologically active. On a world where surface temperatures plummet to around -230 degrees Celsius, scientists had assumed that all geological processes would have frozen to a halt billions of years ago. Yet, the images showed vast, smooth plains with almost no impact craters, suggesting that the surface was young and had been recently resurfaced, geologically speaking. This implied that some form of internal heat was still driving activity, perhaps through processes we do not yet fully understand. The idea of a dynamic, evolving world at the edge of the solar system challenged fundamental theories about how small, icy bodies behave. The spacecraft's instruments also gave us our first close look at Pluto's thin atmosphere. It was found to be composed mainly of nitrogen, with traces of methane and carbon monoxide. More surprisingly, the atmosphere was layered with beautiful blue hazes, which extended high above the surface. These hazes are likely created when sunlight breaks down methane gas, leading to the formation of more complex hydrocarbon molecules. But the biggest atmospheric puzzle was how it was being sustained. Pluto's weak gravity means its atmosphere should be rapidly escaping into space. The fact that it is still there suggests it is being actively replenished from the surface, possibly through cryovolcanism, volcanoes that erupt icy slush instead of molten rock. Even Pluto's family of 5 moons held surprises. Its largest moon, Charon, turned out to be a fascinating world in its own right. It was not a passive, cratered body, but showed evidence of massive tectonic fractures and a strange reddish-brown cap at its north pole. This feature, informally named Mordor Maxima, is thought to be created from gases escaping Pluto's atmosphere, which are then captured by Charon's gravity and frozen onto its surface. The intricate dance between Pluto flyby. The mission completely rewrote the book on Pluto. Among all the incredible features revealed by New Horizons, one stood out above all others: a massive, heart-shaped basin of bright ice, stretching more than 1,000 kilometers across Pluto's surface. The western lobe of this feature, a vast plain named Sputnik Planitia, immediately captured the world's imagination and became the key to understanding the dwarf planet's unexpected activity. This enormous basin is filled with frozen nitrogen, methane, and carbon monoxide, and it is almost completely devoid of impact craters. This lack of craters is the smoking gun for recent geological activity, indicating that the surface is no more than a few million years old, a mere blink of an eye in cosmic terms. The smooth surface of Sputnik Planitia is not static. High-resolution images revealed that the vast sheet of nitrogen ice is broken up into large polygon-shaped cells, typically 20 to 30 kilometers across. Scientists believe these cells are evidence of slow, churning convection. Just like a pot of boiling water, warmer, less dense ice from the bottom of the basin slowly rises, while cooler, denser ice from the surface sinks. This constant, slow turnover continually renews the surface, erasing any craters that might form from meteorite impacts. This process is driven by a small amount of internal heat from Pluto's core, a remnant from its formation, which is just enough to stir the soft nitrogen ice over millions of years. The very existence of Sputnik Planitia has profound implications for Pluto's entire structure. The basin is so massive that its weight likely caused the entire dwarf planet to reorient itself over geological time. It is thought that the basin originally formed from a giant impact. Over time, as it filled with dense nitrogen ice, its immense mass would have created a gravitational anomaly. This would have caused Pluto to slowly tip over, much like a spinning top with a piece of clay stuck to its side, until Sputnik Planitia was aligned opposite Pluto's largest moon, Charon, in a more gravitationally stable position. This process, known as true polar wander, helps explain the current orientation of Pluto's features. Perhaps the most tantalizing theory associated with Sputnik Planitia is the possibility of a liquid water ocean hidden deep beneath the icy shell. The impact that created the basin would have punched a huge hole in Pluto's crust. The weight of the nitrogen ice that later filled it should have caused the crust to sink. However, data suggests the basin is actually a positive mass anomaly, meaning it has more mass than expected. One explanation is that the impact caused an upwelling of denser liquid from below, a subsurface ocean. If true, this ocean would be kept liquid by Pluto's faint internal heat and possibly antifreeze compounds like ammonia, raising incredible questions about the potential for life to exist in such an extreme and unexpected place. Section 5. Beyond Pluto. Journeying into the Kuiper Belt. After its history-making flyby of Pluto in 2015, the New Horizons mission was far from over. With its instruments in excellent condition and with enough power to continue operating for decades, the spacecraft pressed onward, deeper into the Kuiper Belt. This vast, donut-shaped region beyond the orbit of Neptune is a frozen junkyard of primordial objects, remnants from the formation of our solar system more than 4.5 billion years ago. These Kuiper Belt objects, or KBOs, are like cosmic fossils, holding clues to the early history of our planetary neighborhood. New Horizons became the first, and to this day, the only spacecraft to actively explore this mysterious third zone of the solar system. The mission team identified a new target for a close encounter, a small ancient KBO designated 2014 MU69, later officially named Arakoth. On January 1, 2019, New Horizons successfully performed a flyby of this distant object, which was more than 1 billion miles beyond Pluto. The images it sent back were astonishing. Arakoth looked like nothing we had ever seen before. It was a contact binary, composed of two distinct, flattened lobes gently fused together, resembling a lumpy reddish snowman. Its shape provided compelling evidence for how the building blocks of planets, known as planetesimals, might have formed in the early solar system, not through violent collisions, but through a slow, gentle accretion process. The encounter with Arakoth provided a unique snapshot of the primordial solar system. Unlike planets and larger dwarf planets, which have been geologically processed by internal heat, Arakoth appeared to be perfectly preserved. Its surface was smooth, lightly cratered, and had a uniform reddish color. This suggests that it has remained largely untouched since its formation billions of years ago. By studying its composition and structure, scientists can learn about the conditions that existed in the protoplanetary disk from which the Sun and planets were born. Arakoth is a time capsule, offering a direct window into the very dawn of our solar system. Even after its flyby of Arakoth, the journey of new horizons continues. As of today, in late 2025, the spacecraft is still traveling through the outer reaches of the Kuiper Belt, more than 60 times farther from the Sun than the Earth is. Although its propellant is too low to target another specific KBO for a close flyby, its instruments are still active, collecting valuable data. It acts as a unique observatory, measuring the plasma, dust, and gas of the interplanetary medium in this unexplored region. Its mission has evolved from one of specific encounters to a broader exploration of the environment at the very edge of our Sun's influence, sending back data that continues to challenge our models of the solar system. As New Horizons ventures ever farther from the Sun, it continues to make surprising discoveries about the environment of the outer solar system. One of its instruments, the Venetia-Burney Student Dust Counter, or SDC, is designed to measure the impacts of tiny dust particles as the spacecraft speeds through space. These particles are the microscopic debris shed by comets and created by collisions between asteroids and Kuiper Belt objects. By counting these impacts, scientists can build a map of the dust distribution throughout the solar system. For years, the data from the SDC matched predictions quite well. But recently, something has changed, presenting a new and exciting puzzle for scientists to solve. In data collected after July 2023, the SDC began to register a significantly higher number of dust impacts than expected. This was a complete surprise. The prevailing scientific models predicted that as New Horizons traveled beyond about 50 astronomical units, 50 times the Earth-Sun distance, it would pass what is known as the Kuiper Cliff. This was supposed to be a sharp drop-off in the number of Kuiper Belt objects, and therefore, the amount of dust should have decreased. Instead, the dust levels increased. This suggests that the Kuiper Belt does not simply end. It may extend much farther out than we previously believed. Or there is a second, more distant belt of objects we did not know about. This unexpected discovery has profound implications for our understanding of the solar system's architecture. If the Kuiper Belt is indeed much larger, it means there is far more material at the fringes of our system than our models account for. This extra mass could influence the orbits of the outer planets and other distant objects. The source of this additional dust is a mystery. It could be coming from a large population of unseen, small Kuiper Belt objects that are grinding each other down over billions of years. Alternatively, it could be produced by radiation pressure from the Sun, pushing dust from the inner solar system outward, though the recorded levels seem too high for this to be the only explanation. Solving this dusty mystery is a top priority for the New Horizons team. The spacecraft continues to collect data as it travels, and each new measurement helps to refine the picture. This finding highlights the immense value of in-situ exploration, of actually going to a place to measure it directly. No telescope on Earth could have detected this faint, diffuse dust. Only by sending a probe through the region could we discover it. The extra dust is a clear sign that our map of the solar system is incomplete. It points to the existence of more structure and more objects in the cold, dark depths, waiting to be discovered and understood. The strange dust readings from New Horizons are not the only recent clue that our solar system may be hiding more secrets. For years, astronomers have noticed strange anomalies in the orbits of distant objects in the Kuiper Belt. In October 2025, a study proposed a new and compelling explanation for one of these puzzles: the existence of a hidden, undiscovered planet, tentatively named Planet Y. This hypothesis arose from studying the strange tilt of about 50 distant Kuiper Belt objects. Their orbits are inclined by an unusual 15 degrees relative to the main plane of the solar system, an alignment that is very difficult to explain with our current understanding of planetary dynamics. The theory, put forward by researchers at Princeton University, suggests that the gravitational influence of a hidden planet could be responsible for shepherding these Kuiper Belt objects into their strangely tilted orbits. Through extensive computer simulations, the scientists calculated what kind of planet would be needed to produce this effect. Their models point to a world that is larger than Mercury, but smaller than Earth, perhaps a few times our planet's mass. This hypothetical planet Y would be orbiting the Sun at an immense distance, somewhere between 100 and 200 times farther out than Earth. Its distant, inclined orbit would explain why it has remained hidden from our telescopes for so long. It's important to note that this Planet Y is a separate hypothesis from the more famous Planet 9. The Planet 9 theory proposes a much larger planet, perhaps 5 to 10 times the mass of Earth, orbiting even farther out, at a distance of several hundred astronomical units. Planet 9 is hypothesized to explain the clustering of the orbits of a different group of extremely distant objects. The fact that there are now two separate lines of evidence pointing to two different potential hidden planets suggests that the outer solar system may be a far more crowded and complex place than we ever realized. It is possible that both planets exist, or one, or neither. The search for these hidden worlds represents one of the most exciting frontiers in modern astronomy. Finding a new planet in our own solar system would be a monumental discovery, fundamentally changing our map of our cosmic home. The gravitational whispers detected in the orbits of distant Kuiper Belt objects are like faint footprints in the snow, hinting at the presence of something large and unseen moving through the darkness. While the existence of Planet Y is still just a theory, it is a testable one. The hunt is now on, using our most powerful telescopes to scan the dark corners of the sky for a faint point of light moving in just the right way. The tantalizing theories of hidden worlds like Planet Y and the mystery of the extended Kuiper Belt might not remain unsolved for long. A revolutionary new tool is set to begin its work in late 2025, and it has the power to transform our understanding of the outer solar system. This tool is the Vera C. Rubin Observatory, located high in the Andes Mountains of Chile. Its centerpiece is the Simoni Survey Telescope, which boasts a massive 8.4-meter primary mirror and the largest digital camera ever constructed for astronomy. This powerful combination will allow it to conduct an unprecedented survey of the sky. The primary mission of the Rubin Observatory is the Legacy Survey of Space and Time, or LSST. Over the course of 10 years, the observatory will scan the entire visible southern sky every few nights. This rapid, repeated imaging will create a deep, time-lapse movie of the universe, capturing everything that moves or changes. It is expected to discover billions of new stars and galaxies. But for planetary scientists, its most exciting contribution will be its survey of our own solar system. It is predicted to increase the number of known Kuiper Belt objects from a few thousand to tens of thousands, providing an incredibly detailed map of this distant region. This comprehensive map will be crucial for testing the Planet Y hypothesis. If a planet of the predicted size and distance exists, the Rubin Observatory should be able to detect it directly within its first 2 or 3 years of operation. By repeatedly imaging the sky, it can spot the faint, slow-moving object against the background of distant stars. Furthermore, by discovering thousands of new Kuiper Belt objects, the survey will provide a much larger statistical sample to study their orbital patterns. This will allow astronomers to confirm whether the strange 15-degree tilt is a real phenomenon or just a statistical fluke, and to search for other gravitational signatures of hidden planets. The synergy between a deep space mission like New Horizons and a ground-based observatory like Rubin is a perfect example of how modern science works. New Horizons provided the ground truth, the direct in situ measurements of dust that told us something was missing from our models. The Rubin Observatory will provide the big picture, the vast, comprehensive survey needed to find the missing pieces of the puzzle. Together, they represent a powerful 1-2 punch in our quest to understand the outer solar system. The next few years promise to be a golden age of discovery as we finally begin to fill in the blank spaces on our map of our own cosmic backyard. The journey of New Horizons, from its stunning revelations at Pluto to its ongoing discoveries in the Kuiper Belt, is a powerful reminder of a simple truth. The universe is full of surprises. Every time we push the boundaries of exploration, we find things we never expected. We went to Pluto expecting a dead, cratered ice ball and found a vibrant, geologically active world with mountains of ice and a potential subsurface ocean. We traveled into the Kuiper Belt expecting it to end, and instead, we found evidence that it may be far larger and more complex than we ever imagined. These discoveries are not just interesting facts, they fundamentally change our understanding of our place in the cosmos. This ongoing exploration matters because it speaks to the very core of who we are. Curiosity is our compass. The drive to ask what's over the next hill, or what lies beyond that star, has propelled our species forward for millennia. Exploring space is the modern expression of this ancient human impulse. It challenges us to be our best selves, to be more creative, more collaborative, and more daring. The technological challenges of sending a probe across billions of miles of space lead to innovations that benefit us here on Earth, while the scientific discoveries inspire us and expand our perspective, reminding us that we are part of something vast and magnificent. The search for hidden worlds like Planet Y and the quest to understand the true extent of our solar system are not just academic exercises. They are part of a larger search for our own origins. The icy bodies of the Kuiper Belt are the pristine remnants from the birth of our solar system. By studying them, we learn about the raw materials that formed Earth and ultimately ourselves. Understanding how our planetary system is structured, including all its hidden members, helps us understand the processes that create habitable worlds like our own. Every piece of the puzzle we find, no matter how distant, helps us to better understand our own home. As New Horizons continues its lonely voyage towards the edge of the sun's influence, it carries with it our collective curiosity. Its power will eventually fade, and its voice will fall silent, but its legacy will endure. It has opened our eyes to the wonders of the outer solar system, and has set the stage for the next generation of discovery. The questions it has raised about hidden planets, subsurface oceans, and the true size of our solar system will fuel exploration for decades to come. We must continue to follow our curiosity, to build the next observatories and launch the next probes. Because the greatest discoveries are still out there, waiting for us in the great, beautiful unknown.